Okay, in this video we're going to be going through the Chapter 7 exam paper questions. You will find that these aren't whole questions. Quite often in integration and differentiation they're lumped together. So if you just see a part A, there's often a part B to do with integration. Right, let's go on to question 1. Okay, differentiation, remember, we're going to multiply by the power and subtract 1 from that power. So we end up with dy by dx equals 15x squared and 7. And then when we have to differentiate twice, we just multiply by the power, 30x, take 1 away from the power. That's question 1. Question 2. Okay, question 2. Before we differentiate it, we've got to make it look a little bit nicer. We're not going to have any x's in the denominator. So we have y equals 6x minus 4x to the minus 2. Now we can differentiate and we get 6 plus 8x. Minus 2 take away 1 is minus 3. Remembering that minus 2 times minus 4 gives you plus 8. Okay, moving on to question 3. Again, got to make the x's in the denominator up to the numerator. So we have 2x squared minus 6x to the minus 3. Now we can differentiate. 2 times 2 is 4x. Minus 3 times minus 6 is plus 18. Minus 3, take away 1 is minus 4. Okay, moving on to question 4. This square root symbol, if we're going to write that using indices, this is just x to the power of 4 add 6x to the half. So when we differentiate it, we get 4x cubed. A half times 6 is 3. A half take away 1 is minus a half. For part B, there are a few things that we can do before we make it look a little bit nicer. We can multiply out the top, so we get x squared add 8x add 16. Now you can either separate each part to have x squared over x add 8x over x add 16 over x, or, as I prefer to do, multiply all of the top by x to the minus 1. Either way, you'll still end up with x add 8 add 16x to the minus 1. Now we can differentiate it. And we get 1 minus 16x to the minus 2. Okay, moving on to question 5. This does actually say, I think, to the power of, it could say to the power of minus a half, or it could just say to the power of a half. If we treat it as to the power of minus a half, which I think it is in the original question, when we differentiate, we get 3 times 4, which is 12x. Take away 1 from the power, so I have x squared. When we differentiate a constant, it disappears. Minus a half times 2 is minus 1. And minus a half take away 1 is minus 3 over 2. If you had treated it as to the power of a half, you would have got 12x squared plus x to the minus a half. So it just depends on what you read that bit of the question to be. Okay, moving on to question 6. This is actually 3x squared add 4x to the half. So when we differentiate it the first time, 3 times 2 is 6x. A half times 4 is 2. And take away 1 from a half, minus a half. When we differentiate it twice, we get just 6. Minus a half times 2 is minus 1. Minus a half, take away 1 is minus 3 over 2. And that's question 6. Okay, question 7 leads you into it nicely. It actually says write it out where you have just x's in the numerator, nothing in the denominator. So we have x to the minus 1 multiplied by 2x to the half, add 3. We multiply that out. A half, take away 1 is x to the minus a half, and then we have 3x to the minus 1. So it says we write it out in the form of 2x to the p, add 3x to the q, where p and q are constants. So p we've just found to be minus a half, and q we've just found to be minus 1. Given that y equals all of this, differentiate. So we've got y equals 5x minus 7, add all of this, so add 2x to the minus a half, add 3x to the minus 1. Now we can differentiate it. It does say simplifying the coefficient of each term. So dy by dx, 5x becomes 5, the minus 7 disappears, minus a half times 2 is just minus 1, minus a half take away 1 is minus 3 over 2, minus 1 times 3 is minus 3, take away 1 from minus 1 and you get left with minus 2. And that's it. Okay, question 8. So part A, just differentiate it. So f dash of x is 3 add 3x squared. It says given that f dash of x equals 15, find x. So that means the gradient is 15. So we have 15 equals 3 add 3x squared. We take away 3 and we have 12 equals 3x squared. We divide by 3 and we have 4 equals x squared. And the square root of 4, x is plus or minus 2. It says in the question that x has got to be greater than 0, so x is just 2. Okay, moving on to question 9. We need to neaten it up quite a bit before we can differentiate it. It does say to write down the value of p and q. So we have x to the power of minus a half multiplied by 2x squared minus x to the 3 over 2. When we expand the bracket, we get left with 2. 2 minus a half is 3 over 2. 3 over 2, take away a half, is just 1. We need to find out what p and q are. P is the power of this term, so p is 3 over 2, and q is the power of the second term. Okay, given that y equals all of this, now differentiate it, simplifying the coefficient of each term. So for part B, y equals 5x to the power of 4, take away 3, add 2x to the 3 over 2, minus x. Going to differentiate dy by dx to give us 4 times 5, which is 20x, take away 1 from the power. The constant disappears. 3 over 2 times 2 is 6 over 2, which is 3. We're going to take away 1 from the power, so we get a half. And minus x just becomes minus 1. And that's it. Okay, we're going to rationalise it before we differentiate it again. So y is 2x cubed, add 3x to the minus 2. When we differentiate it, we get 6x squared minus 6x to the minus 3. Notice again, all the way through, you've noticed in just part A's, part B will have been linked with the integration questions. So when we do whole past papers, you will see how the rest of these questions develop. Okay, on the last question of the booklet now. It's quite nice. It says show that f of x equals this, so we know that when we do rationalise this and expand the brackets, we will have got the right answer. If we don't get the right answer, we can then carry on with part B and C using what Excel have given us in Edexcel have given us in the question. So let's have a go at trying to rationalise it. We've got a double bracket, 3 minus 4x to the half squared, all divided by x to the half. So let's get rid of the double bracket first. 3 minus 4x to the half, bracket 3 minus 4x to the half. Multiply this out. 3 times 3 is 9. 3 times minus 4x to the half is minus 12x to the half. Again, another minus 12x to the half. Minus 4 times minus 4 is plus 16. X to the half times x to the half is x to the power of 1. And that is all divided by x to the half. So when we rationalise it, we bring up the x to the half at the top. So we've got x to the minus the half. And we're going to multiply that by 9 minus 24x to the half. Add 16x. When we expand this bracket, we get 9x to the minus a half minus 24. Minus a half, add a half is 0, so there's no x term here. Add 16 minus a half, add a half, sorry, minus a half, add 1 is positive a half. And if we refer back to the question, this says show that f of x equals 9x to the minus a half, add a x to the half, add b, where a and b are constants to be found. So a is 16 and b equals minus 24. So part B, we're just going to go and differentiate this. So we end up with minus 9 over 2, x to the minus 3 over 2. The constant disappears. A half times 16 is 8x. A half, take away a half, is minus a half. And then part C says evaluate when x equals 9. It's not great to have these negative powers of x, so this looks a lot nicer if we have minus 9 over 2 times 1 over the square root of x cubed, add 8 times 1 over the square root of x. So when we put in 9, we've got minus 9 over 2 times 1 over the square root of 9 cubed, add 8 times 1 over the square root of 9. This gives us minus 9 over 2. 1 over the square root of 9 is 1 over 3. If we cube the 3, we get 1 over 27. And this becomes 8 over 3. Carrying on then, we get minus 9 over 54, add 8 over 3. This simplifies to minus 1 over 6, add 8 over 3, and simplifies again to minus 1 over 6, add 16 over 6, which is 15 over 6, or 2.5. So 15 over 6 is fine, 2.5 is also fine. Thank you, that's the end of the booklet.